Hello, my name's Debbie and I'm your adult education tutor for the online maths recorded course. Welcome to week 3. Hope you're all well and looking forward to continuing with addition. Here we go. All up. Fabulous. So, there's my email address should you need it to ask anything, any inquiries, anything at all, and the link so you can find out about more courses offered by Coventry City Council. There's a telephone number for the same reasons, just to remind you that we are committed to school safeguarding and safeguarding to yourselves, prevent agenda, and the British values and rules for life, which are promoted in your children's schools. More information, the record session will be about 45 minutes approximately. This is week 3 of 5. Feel free to pause to take a break if you need to. And in this session, we will be looking at addition into Key Stage 1 and 2, following on from last week. Place value. Some more work on partitioning again into Key Stage 2. Inverse, and some more vocabulary and keywords. And again, there'll be some more games and resources for you. Please just take a moment to have a think about where you'd put yourself within that at the moment. Do you feel like you know much about Key Stage 2 partitioning? Would you be red, completely new to it? Orange, you've got a bit of knowledge you'd like to build on. Yellow, you're pretty confident. Or green, got it totally. Have a think about where you are now, and we'll do the same at the end of the session. Hopefully, you'll be feeling a bit more confident. Just to remind you of the task images, if you see the man with a thought bubble, have a think. And if you see the notepad, please just jot down. It might be something to have a go at working out, or some ideas that might be useful for yourself. Okay, all for your own learning. So, just wondered which activities you might have had a chance to try at home last week. Did you do anything with the Numicon boards or the spinner game? Would you try anything again? Anything that you'd change? Place value cards, you managed to print those off yet? Did a bit of a go with the Lego? If you haven't had a chance yet, perhaps you could think about something that you might like to have a try this week if you get the opportunity. There were some quite good games. There were some good games there last week. So, just to remind you again, in week 1 we talked about the concrete, pictorial and abstract as a way of teaching maths and how we move through the phases. Here's an example again. So this can be used into Key Stage 1 and 2 as well as a way of introducing a topic and aiding the children to understand and reason with it. The idea being that you move through these stages to make sure they're secure in the idea and the foundations of the topic before they start doing it with trickier numbers, decimals, that sort of thing. We get them really secure by seeing how it works. So this problem, Jonas bakes 20 cookies, he gives 8 to a friend. How many does he have left? So initially we start with the concrete, the pictures of those cookies. Yeah, so you can see he's got 20 cookies there that have been split out into the 8 on the right that he's given away and the other side that he's got left. So how many has he got left? You count those on that side. Okay, move on to the pictorial then. From the concrete, you can start looking at a number line or as you can see, they've used cubes there that they've drawn across. So there are 12 cubes left, therefore there must be 12 cookies left. Okay, and then we can go into bars as well, which becomes the abstract, okay, where we might have a sum 8 plus question mark equals 20. Okay, what's the missing number? Okay, and then we start, that leads us into part of what we'll be looking at today, which is the inverse, where we look at the opposites. So again, the whole idea is that children initially need to see what they might have to do with the problem with the real objects, which can then be broken down into using cubes and then into using number lines, and eventually they'll just be able to write a number sentence, a sum, and solve it. So a big part of what we're going to be thinking about this week, the base 10s or the deans. If I show you this picture, certainly something I remember from school, there were plastic cubes, plastic grids, and then plastic 10s and the plastic 1s or units as they were called at the time. So basically these are used in maths quite often for children, particularly when they're at that initial phase, the concrete phase, to represent our hundreds, tens, units and the thousands. Okay, units being known as ones now. So your thousands is the cube you can see, your hundreds, the 100 square, your thin ones are your tens, and then your individual ones are your ones. Okay, and this is a really clear, really concrete way of representing numbers and replace value. You can see that 1,000 square is worth a lot more than a 1. Okay, and the idea of you need 1,000 of these to make this. It's about getting children to understand how these numbers relate to each other. Okay, if they can get it with the concrete, if they can see it and feel it and use it and test it, when they come to do it in a more abstract or pictorial way, that foundation is there, and that helps promote their confidence and what they can do with it. It makes them more successful with maths, which is really important. I think confidence is quite often a thing with maths. So for instance, if you're asked to make 17 in maths, it would be they'd get 110 and 7 ones. If they're asked to make 117, it would be 100 grid, 110 and 7 ones. Okay, and for instance, if they're asked to make 81, you get 8 of the 10 strips and 1 of the ones. If they were then asked to make 281, would they have to start again, or could they add something to it? And it's about getting them to realise at this point, oh, I'm going to get 2 more counters. Oh, is it 2 ones? It's 2. Look at the grid, it's 2 hundreds. Okay, it's about getting children to understand the value of the number in relation to each other. It's not 2, it's hundreds. When we take the HTO off the top, it's about them still realising that. So on this one then, let's look at it together. This is how we begin to go from the concrete, holding these objects, into the abstract. So here we've got how many groups of 10s and 1s are there. So this is just a really good example of a worksheet. So if you look at the strips, they're 10s. So how many 10s have the children got? Okay, so we'd be saying here we'd say we've got 5 10s and how many 1s? So 5 10s, 1 1. Yep, so we've got, what's 5 10s? We've got 50 plus 1, and that equals 51. Yep. Trying to avoid making the mistake of saying we've got 5 plus 1, because we haven't. You can see that there, we've actually got 50 plus 1. Okay. You can have a go at the ones further down the grid with your notepad. You could pause me here, have a go at those yourself. That'd be great. Okay, looking at this one then. Here you go. You can see how they've actually used the concrete objects here to put them into the hundreds, tens, and U there for units, but you get the gist. It should be ones now. Okay, so you've got 2 in the hundreds column, 3 in the tens column, and 4 in the ones column. Okay, so your number is 234. It's not 234. It's 200s, 3 tens, and 4 ones. Okay, so it's all about making sure children are secure in that. Okay, what calculation does this show then? Okay, so looking at the first pile, what have we got? We've got 2 10s and 5 1s. So we've got 2 10s and 5 1s, yeah, 25. And the second pile, how many 10s have we got? We've got 4 10s and 7 1s. So our calculation would be to add those together. Yeah, you see that? Super stuff. So that would be your calculation. 25 plus 47. Okay. Some more for you to have a look at here. Have a look at these yourself. So the first one then, how many 10s have we got? We've got 4 10s and 1 unit. What's that give us? 41. Yeah, we'll be adding to that 2 10s and 4 units. So our sum this time would be 41. Add 24. Can you see that? We were working that one out. Okay. This is going into column addition, which we'll come on to a bit later on, because children do that as they move through school. But I'm just showing you it in columns so that you can see where the 10s and the 1s go. Yeah. Just because you can't see the 0 on the 25 as in 2 10s doesn't mean it's not there. And that's the thing we've got to remember. It belongs in the 10s column because it's 2 10s. It's not just 2. Okay, and that's the thing we have to really encourage the children to get to grips with. Once the children become a bit more confident with this, we can start thinking, instead of using the 10 strips, 1,000 cubes, we can start actually just using counters. Okay, and you'd have a different colour for each amount. Okay, initially you might have a H on the hundreds, a T on the 10s, and there's an O on the 1s, but thinking at this, we're moving ahead of it. Okay, so this example here, once they're secure, they don't need necessarily the size to show them. Okay, it doesn't have to be big if it's 100. Okay, we just can remember 100 is what's 100, 10 is worth 10. So in this case, the purple is hundreds, the blues are the tens, and the red are the ones. So what's our number? We've got 100, 4 tens, and 2 ones. So 142. There we go. Have a look at this one. I'm going to put an answer in here for us. I think we've got 5 hundreds, 4 tens, and 1 1, 541. Would you agree? Have a look. No, where's the error? There's 5 tens, aren't there? So there's actually 551. Okay. So once children are used to using these place value counters, and as you can see here, these are the ones with the amounts written on them. Okay. So the same size, just they're just color coded. Okay, they can start to do sums in this way. So again, we're still using concrete at this point, but we're moving into the pictorial in terms of it's not bigger when it's 1,000 and smaller when it's a what. You know, these are now just becoming representative. Okay, so children can have a go at making their own sums. So on this one, what have we got here? We've got 500s. How many tens? 7 tens. And 1 unit. What's our number? 571. Yeah. So you can see how children move through these phases as they become more confident. They can start to do calculations. So in this instance, across the first line, you've got 1,232. On the second line, you've got 3,100, 110, and 4 ones. And you can add those together. Again, a bit like the columns, you can add up your columns. Okay, let's have a look at doing that one together then. So if you were adding you'd have, this time we're going to thousands, hundreds, tens and ones. Please jot it down if you've got some paper. So I would have 4,000s, 300s, and 4 tens and 6 ones. Yeah. Counting them up, I'm just totting them up together, and that's what I would end up with. Okay. Again, so this might seem quite simple to you because you know how to do it, but for children who are still getting to grasps with the fact that each of those counters has got a different value, this is really just about securing that. Okay. So you can use place value boards and counters, as we've just explained. So in this instance, slightly simpler number, we're doing first number, 3 tens and 2 ones, 32. Children begin to pick that up really quickly. Second number, across the bottom, 4 tens and 6 ones, 46. Okay, and they could use this to do their sums. They could literally push all of those together and count them. Yeah, count them in tens. So they count their tens, 10, 20, 30, 40, 50, 60, 70. Now count your ones. 1, 2, 3, 4, 5, 6, 7, 8. So if you've got 70 and you've got 8 ones, what we got? 78. Yeah, as I say, seems simple when we're doing it, but for the children it does take a bit more. Okay, I think we're a bit stuck. No, we're not. Okay, so then we move to abstract. Once the children are more confident about the tens and the ones, we stop giving them counters and we start just writing it down, which is kind of, I guess, what I've been showing you as well. Okay, so we stop actually saying put 70 there, 1, 2, 3, 4, 5, 6, 7 tens, and we just know that it's 7 tens. Okay, and they can move on to literally having numbers like this. So at the moment we've got 2 tens and 3 ones, 23, and to that they're adding 4 tens and 5 ones, 45. Okay, and that's literally what they're doing. They would add their ones together, they would add their tens together. Initially this is quite simple, so long as our ones stay below 10, we don't have to do any transferring. So at the minute we could literally do, what's 3 plus 5? That's our 8. What's 2 plus 4? That's our 6. And there's 68. When we're first showing this to children, we do it so there's no carrying over, there's no going over the 9 with the ones or the tens or the hundreds. Okay, so they can see the operation first before we make it more complex. So we'd start talking about inverse of numbers, okay? So inverse is literally the opposite. Inverse means we're doing the opposite. We turn the operation round or the number sentence round, okay? So children will be taught to use addition to solve problems that involve doing the opposite. So they start relating addition to subtraction, okay? And this starts from year one, okay? Simply in year one, but it starts from year one. So here's an example. So in year one, they might be given a problem like this. 5 plus something, missing number, equals 12. And they've got to use what they know to find out the answer. So what would you do? If you were thinking about using the inverse, using subtraction, how could you use subtraction to solve that? What would you do? We've got 12. We've got 5, and we're going to use subtraction. Start with the largest number because it's subtraction. 12 take away 5 equals, not sure? Do your 12 dots, take 5 away. It's fine to use a pictorial to help you. Most of us would know that's 7, yeah? And then if we know 12 take away 5 equals 7, remembering that we can switch these around, it's the inverse, it's the opposite. We might know that 5 add 7 equals 12. We might know that 12 subtract 7 equals 5. And we might know that 7 add 5 equals 12. So it's looking at the relationships between numbers, okay? We start that very simply in year 1. Year 2, just to give you an example of what they might be looking at, they go into 2-digit numbers, okay, so it gets trickier. Same concept, but just using 2-digit numbers, larger numbers. In year 3, we go into the hundreds with it. Year 4 into the thousands, just getting trickier. And then in year 5 and year 6, we start looking at decimals, okay. Once you've got the concept, once they've really got that concrete of it nailed down, actually, so long as they know what they're doing and why, as you go into larger numbers and then into decimals, it shouldn't be that much more difficult. It's the same operation. They just need the confidence to deal with the larger and the trickier numbers. And if we can make sure this is embedded well to start with, get the concrete down, that will be easy enough to do, okay? So a big thing with this as well, with confidence and helping the children, that we really push is use what you already know. Okay, so if you see a problem or you're presented with something in life and you don't know how to deal with it, use what you can relate to it. What do you already know? So for instance, if you know 2 plus 3, 2 add 3 equals 5, then you know what 3 plus 2 is, because like we've just shown with this example, it's the inverse. It's about switching numbers around and doing opposite operations, okay? If you know 3 plus 2, you also know 20 plus 30. 2 plus 3, 20 plus 30. Think about our place value. This is why children are taught place value from early on. Yeah. If it's now 2 tens and 3 tens, it's going to make 5 tens. If you know 2 plus 3, you know 2 billion and 3 billion. Yeah. And you will, believe it or not, your children, particularly by year 5 and 6, will know what 0.02 plus 0.03 is. Okay, it's all about the relationships between numbers and the confidence of knowing that you do know. Okay, and you know, even if it's just making a plausible guess, even if it's just knowing there's going to be a 5 in there somewhere, that's a really good way of using your strategy and the method and the facts that you know. Okay, and this is all about what maths is about: problem solving. Okay, using what you know. So again, if you knew what 40 or 20 equals, you could use that with 4 plus 2. With this sort of game. Again, I'll make sure that you get all these resources again this week. So again, same sort of thing as the one I gave out last week, but now we're going into those tens numbers. Okay, so rather than, for instance, the first one 4 plus 2, we're doing 40 plus 20. Rather than 7 plus 3, we're doing 70 plus 30. But if you know 7 add 3 is 10, then 70 plus 30 isn't that far of a stretch. It's about stopping that panic when new numbers come your way, and it's about, I know this, I'm concrete in this, let's do it. It's confidence. Another one then, how many sandwiches are there? Okay, so simple way of doing it here, 6 plus 8 or 8 plus 6, depending on which way you looked at it. What method did you use? What strategy? Did you go across the top? There's 7 across the top. I know there's 2 lots of 7, so did you maybe do multiplication? Did you find 10 and then count how many more were left after that? Did you skip Counting? Did you count in 2s across the bottom? How about 5s? Maybe you counted in 5s. Lots of different strategies to come to the same end, and everybody will naturally have a preference about, you know, if they're really confident in counting in 2s, that might be where they go to. If they like building things up to the next 10, that might be where they go to. Okay, so long as you get to the right answer and you know why you've done what you've done, it's your own strategy, that's okay. So addition on a number line. Okay, so bridging through 10. So once we stop with these simple ones that don't go over 10s, we start bridging through 10 and we teach on a number line first. Okay, so for instance, 8 plus 5, if you have a look at the number line they've got there, they got to the nearest 10 first. They added 2 on because that got them to 10. Okay, they knew from that 5 there were another 3 left, so and they knew 10 plus 3 was 13. Okay, if you don't know 8 plus 5 off the top of your head, that's quite a sensible way of doing it. Get to your nearest 10. What have I added? What more do I need? Counting in 10s. Okay, so for instance, this example is 23 plus 20. Thinking about the 100 square, you know, all of this comes back together. They might not have 100 square in front of them, but they might in their mind remember what they did on the numbers on the 100 square and what happened to the number. So they might count in 10s. 23. If I went down, that counted in 10, it would be 33. And if I went down again, it'd be 43. They might remember that. Counting in multiples of 10. So this time, if it's 37 plus 20, they might be able to count in 20s. Again, thinking about the 100 squares that they used, they might just be able to use a number line and know that 20 more than 37 is 57 and just check it. Number lines are good for checking your answers as well. They might count in multiples of 10s and 1s. So for example here, 35 plus 23, you might count on your 20 and then count on your 3. Okay, lots of different ways to do it. In year 2, thinking about the 100 square we've just been talking about here, for example, 14 plus 12. So we've learned by this point using our 100 squares, we go down the 100 square for 10 more. So you jump down and then you're going to go across 2 more for your 2 1s. Yep, so 1 10 and 2 1. So we're thinking about the place value again, yeah, to get to the answer of 26. Okay, they're still able to use the tools if they need them at this point. There's no whipping these things away until children are ready. There is no point moving on to your abstract until the children are concrete. Okay, they need to understand why they're doing what they're doing. Whipping those tools away before it's too soon, it won't help them. Okay, and schools know this. Okay, these ones are a bit harder then because they start to cross the 10s. Okay, so the first one, 54 plus 29. Now, one way that your children may well be taught this is we're counting 10s. So 54 is what we're starting with. It's a larger number. We're going to add up. We're going to count on 29. What is 29 really close to? What's the nearest 10? It's 30. Okay. Would that be easy to do? 54 add 30. Think about your 100 square. Get your 100 square out. Get your number line out. I was doing it. I'd go into my number square and I'd count on 30. 54, 64, 74, 84. Okay, is my answer 84? No, because I wasn't supposed to add on 30, was it? It was 29. I'm just going to count back 1 space. Yeah, I've got to 83. Okay, go in your 10s, that's absolutely fine. It's 134 at 82, crosses to the hundreds. Again, you might decide that you can add on your 80s. You might decide to start with your 82 because it's the bigger number. Again, that would be quite sensible, wouldn't it? You haven't got quite so much to add on. Yeah. And count it that way. So you might do your 80, 82. Right, so I'm going to add on 30. Okay, 82, 92, 102, 112. What have you got left? The 4, 112, 113, 14, 15, 116. Okay, they've got to get the concept of how to cross into the hundreds first. So again, until they're solid in how that works with their number lines, it's not going to figure, but just helping them to understand and getting their place value in place first will really help with that. And then ones such as 89 and 67, which will cross the 10s and the hundreds. Okay, so it's about breaking that down gradually as well. Okay, again, 89, I'd be tempted to round up to 90 because that would make it easier, but just remember that you've added 1 there, so you're going to have to take 1 off at the end. Yeah, you could even round up to 100. 100 add 67. 167, yeah, 106, 10 and 7, but then I need to take the 11 back off. Okay, the strategies, they all, you know, they can all work. Okay, it's about finding a thing that works for you. Just remind you of this again, children will only move to formal written methods if they're able to complete these things. They need to know the place value of digits in whole numbers and decimals. There's no point thinking that 4 tens is 4. They've got to know it's 40, okay? They've got to get that, okay? Otherwise, they're not ready for it, okay? They need to know all addition facts for numbers up to 20 by heart, so all the different number bonds to 20. They need to be able to add at least 3 single digits mentally, so that would be up to numbers of 100. They need to understand 0 as a placeholder, as in if there's 0 tens, it doesn't mean there's nothing there and we put the hundreds in there. 0 is 0 tens stands. They need to be able to add a pair of 2-digit numbers mentally, okay? It's about confidence again. If the children haven't got these basic skills, there's no point setting them up with sums, even, you know, with 100, let alone 1,000 and tens of thousands and into the millions. It's too much. Okay, so in year 3, we're moving up in addition a bit further. Once children are secure with place value, they can start looking at column addition. Now, to start with, they use the expanded method, which is what I'm going to show you here, okay? And the reason they do this is to make sure they've absolutely got the value of the hundreds, the tens, and the ones. So, for instance, taking the example on the screen, I'll split it down a bit further. So, 67, 6 tens, 7 ones, and we're going to add 56 to it. Yeah, follow me so far? Okay, so first of all, we're going to add our ones together. Okay, so we've got 7 add 6. Okay, and if you look, that gives us our 13. Happy with that? 1, 10, 3 ones. Okay. Next, we're going to add our tens together, but we must remember, and this is a really important thing to hit home to the children, that they are tens. It's not 6 add 5, it's 60 add 50, and that's really important that we hammer that home. 60 add 50, the little sum at the side there, okay? It's fine if they need to be doing this to start with. 60 add 50 is 110, okay? So my answer isn't 11, because if I put 11 underneath 13, I've got the sum completely wrong. My answer is 110. Okay, add those 2 bits together because we've kind of done 2 addition sums within. That's how we get to our 123. Okay, so that's our expanded method. At this point, we're writing down our answers to both parts. We're spreading out, adding up those tens together just to make it really explicit to the children. Okay, so this is the expanded method. So we'll go at this one then. See if you can do this one. Get your notepad out. 65 and 34 using the expanded method. Think about your tens and your ones. So you probably write it out like this to start with. 65 add 34. So we'd add our ones together first. 5 add 1. 5 add 4 even. 5 add 4 would give us our 9. Yeah. We'd add our tens together next. Is it 6 add 3? No, it's 60. Remember, we're in the tens column. Add 30 would give us our 90. We've expanded that out again so you can see 90 plus 9 gives us our answer, which is 99. Okay, this is the way they're shown first. Okay, once they're secure and expanding it out, we can move into column addition. Okay. Each column is added individually, the ones, tens, hundreds, thousands, etc. With the foundation knowledge that although each one is represented by 1 digit, we know its place value. So we know the 4 in the thousands column is 4,000, not just 4. Yeah, and it's really hammering that home. That's why we expand, expand, expand until they get it. Okay, so we've got any of these, feel free to pause and have a little go yourself. See if you can get to the same answers. We're going to go one together. Using that column method now, and we're going to go writing this down and have a look together. So we've got 654. And you're going to add 827. There's going to be some carrying over. Okay, there's going to be some exchanges here going on. Okay, so let's have a look together. Start the ones end. Okay. So my first addition here is 4 add 7. Yeah. Again, I would instantly turn it around on its head. Start with 7, add on 4. It's just easy to start with a bigger number. What's my answer? 11. Now, what's 11 got in it? It's got 1. 1 and 110. So I carry 1 over into the tens column. Okay, put it under there, the 110, so that we know it's there ready to add on. Okay, add up the tens. So we've got 5 tens and 2 tens. Remember the tens. 50 and 20 equals 70. And 1 more 10 here underneath to carry over, it's 80. So we've got 8 tens in there. Okay, see that? Now we add the hundreds together. So we've got 600s and 800s again. I'd automatically put the 80 in my head and count on 6 more. 800 and 600 is 1400. Yep, we're going to go into our thousands, aren't we? We haven't got anything to carry over. So we've got 400s and 1000. 1481. Okay. Okay, so moving into year 4 now. Again, using the column addition. Let's try this next one. Let's try and do, so again, we're going to larger numbers now. Okay, we're going to need tens of thousands. Okay, because again, we're going to larger numbers and this is how we build on it. So we're going to do 7,632. And we're going to add on 3,919. Oops, daisy, that's not a very straight line, is it? Okay. So again, we start with the ones. Okay, get your notepad out. Let's do this together. Okay, so we've got 2 ones and 9 ones. 9 plus 2 is 11. That's too much to put in one column because it's got a 10 to it. So we put the 1 1 in here and we carry that other one across. The 1 10 we carry across. Okay, so we've got 1 1 1 and 10 1s. So we've got 1 10 to carry across. The 10s then, 3 plus 1 is 40. 1 more 10 making 50. So 5 10s is 50 power 5 in there. 6 plus 9 in the hundreds column. Spin it round. 9 plus 6. Got 15. Nothing to carry. So 1500. How does that work? That's 1000. Let's put it underneath. And 500. There we go. Add up our thousands. We've got 7 plus 3 is 10,000. Am I finished there? No, I've got my 1 down here to carry over. So I've actually got 11,000. Okay, so that's 1,001 tens of thousands. My answer is 11,551. Okay, the tens, the hundreds of thousands, the tens of thousands, the hundreds of thousands, the millions, it takes a bit of getting your tongue around. But the process works the same. And that's the thing. In year 3, we start to teach them to do it. We go from expanded to column. And then we start to get into larger numbers. And all it is, it's about making sure that we're correct throughout. So if you're adding numbers that have got 5 digits, there's more scope for making a simple mistake. So the idea is it's just about, as we become more confident and competent, we can do it with larger numbers. Okay. And we also start to think about money. And this is the reason why decimal is quite important. Obviously, because within our monetary system, we use decimal. So for instance, here we have £7.30 and £5.60. Okay. Now, I've written that out as so. You can put your dots in. £7.30, £5.60. Make sure it's lined up. Okay. Actually, if it was 56 pence, 5 and 6 should be over there. Make sure your dots line up. Your points. Okay, it's important. So same again, 0, it doesn't matter what you're adding together, and this is the point we get across at the end of year 4, I think, with this. 0 add 0 is 0, so you've still got 0 ones. 3 10s and 6 10s is 9 10s, 90. You need your dot in the same place in your answer, obviously. 7 add 5 is 12. So how are we going to do that? We're going to carry 1 over, aren't we? And there's our 200s. Nothing else in this column, so we just put this in. So in terms of this, our answer is 1,200, 9 tens and 0 units, which in terms of money, which is why what we're looking at with a decimal point, would be £12.90. Yeah. Children initially look at decimals and panic. You put the money into it and it makes a bit more sense and it's a bit more useful to them. Okay. Obviously a bit tricky with exchanges, but that's why we practice. Okay. That's why we do everything else first, that we can see why we need that. Into year 5, again, they go into larger numbers. So again, we're going to hundreds of thousands. with more exchanges and more carrying across. Various place value. This is where I was saying about with the decimals, making sure that they line up. So for instance, if they asked you to add up, okay, we're going to come up, that's year 6 actually. We'll stick with this. So this is your formal methods with decimals, similar to what I've just shown you. Into year 6, we start putting the decimals in different places. So you might be asked to add up 2.94 and 16.5. And your natural might be to go 16.5. Let me show you this. So 2.94 and 16.5. Just have a look at that. Can you see a problem with it straight away? Yeah, the problem is the decimal points aren't in the same place. And all that is that our columns are wrong, okay? Let's have a look at that again. So actually what I should have done, it should be 2.94. And the number underneath I need to adjust. So it should be, in order to keep the decimal point in the same place, everything before the decimal point needs to come before the decimal point here. So it would be 6 in this column, 1 in this column, 5 in this column. And you can put the 0 in it. There's nothing there, which is why they haven't written anything, if you like. But that would be the correct way of doing it. You've got to make your decimal points line up. And this is part of the complication in year 6 because they start doing it with numbers that have got a different number of place value. And it's not simple. They have to line up those decimals themselves, okay? To work out it's still a very similar way, but they've got to be really clear in how they're doing this and why they're doing it. It gets trickier that way. Okay, looking at that. So here are the web addresses, same as week 2 because addition carries on, but there are some really good games and activities on there that I'd advise you to have a look at for your older children as well. This week, a couple of activities that I'll make sure are sent out to you as well. Using the known facts game that I showed you with the spinner. So this is where we take 2 plus 4, but we use it with 20 plus 40, for instance. And there's a nice counting game for younger children as well, talking about more and less and fewer and more, about the language of addition, which is also really good to do. So just to run through this week, we've talked a lot about resources and vocabulary used in school, about the Dean's cubes and the place value counters and those sorts of things. We've looked at some year group expectations. Obviously, addition is just one part of maths, and it does feed into lots of other parts, lots of the other operations and the things that we taught to do. But this gives you an idea of how addition builds up, I guess, how you can see how it builds on and why the place value we do down maybe in Key Stage 1 links into Key Stage 2, why it's so important to embed those foundations. You know, we're not just getting cubes out to build blocks with and for the children to be distracted by, we're actually teaching them with the very physical, and lots of children are kinesthetic learners. They need to feel and touch and experience first. And this really builds into this, and it's confidence boosting. It's boosts their confidence because then they're more interested in doing it. Lots of people think they can't do maths. They've been put off by maths, and actually we really need to turn that around, and hopefully by making them confident learners and build up their skills, that will really help. We've looked at the use of place value counters and deans. We've looked at the expanded method and the column method for addition, and some more activities and games to play. I'd just say to you again, we shall stop taught in 2 weeks through the whole of primary addition. If your child is in year 3 and have just had 4 months off with the COVID and, you know, don't think they must be doing everything that's in year 3 or else, this might just give you a guide of where you could help them. Go back to the year 2 bits we looked at and just see, are they doing all of this? If not, is there anything you could help them with there? This is to help you understand what they're doing and when they're doing it. It's not to make you think, oh, the child's not doing this, is terrible. But hopefully you'll understand a bit more about what they're coming home with and what they're talking about when they talk about things like vocabulary, like the expanded method or the column method and decimals and things. It might just help you out with that. If I can just ask you to reflect again, please, at the end of these 2 sessions, how are you feeling about Key Stage 1 into Key Stage 2 addition? Do you fully understand it now? Understand most of it? Would you be yellow, orange if you understand some of it, and red if you're still not feeling confident? Thinking about the session again, how's it been helpful? and what would you like more help with? And if there's anything that you think about from these questions, please do email it to me, because it, as I say, it helps improve the sessions in the future. And if there is anything extra you need, then I'm more than happy to try and help you or point you in the right direction if I can't help you myself. I'll send these activities home as well, as I've already mentioned. I'll send them through the links and the attachments to the email for you to use. So next week, we're moving on to subtraction, understanding how it's taught in school. There'll be some more activities and online links for that. Okay, and again, thinking about the inverse of addition. So some of what we've looked at will be similar, but subtraction just throw a bit more into it, makes it a little bit more complicated. Okay. Thank you for attending. I hope you found the sessions useful. There's my email address again, should you want to contact me. And there's the links, should you want to find out more about more courses that Coventry have got to offer. Hope you have a really good week and you enjoy some of the activities, and I'll see you next time. Thank you.